Hi everyone, we'll solve the fifth worksheet today. So the questions are about chain rules and tangent line. So let's start. The first question is about derivative. So, okay. Here we have f of x, which is defined by this sinus 4x times cosinus 5x, okay? So how do we compute the derivative? We know if we had g of x times h of x, we know f prime of x equals to g prime h plus h prime g, right? We know this. And if we have some function which is a composition, we find this one's derivative, let's call it h. We find h prime as follows: f prime of g of x times g prime of x, okay? You should know this. This is chain rule. So here we have sinus, okay, this function sinus, and inside of it we have another function which is 4x. So before we had sinus x, right? In the previous classes we had sinus x, cosinus x. Okay, we see the sinus x, the derivative of sinus x, we saw that it is cosinus x. This is because first we take the derivative of sinus, which is cosinus. Okay, the derivative of sinus is cosinus. And inside we have x, okay, this x. And the derivative of x, it's 1. That's why we don't write anything at all. Okay, but here we have 4x, so we need to take its derivative too. Okay, so this one derivative. So let's find it together. So what's the derivative of this? It is 4 cosinus 4x, okay, times the second function, plus sinus 4x times this one's derivative, which is, first we take the derivative of cosinus, which is minus sinus, okay? Here we have, that's why we have minus. So we have first minus sinus 5x, okay? Then the inside function's derivative, which is 5, okay? So at the end, we have this equality. What about this? We can write it as in this form, okay? 1 plus second x to the 1 over 3. So how do we take its derivative? First, we take this one's derivative, which is 1 over 3 times this one's to the 1 over 3 minus 1. And inside function's derivative, which is this, okay? So you know already how to derivate this one. It's equal to that, okay? So you have second tangent x over this part, okay? For this one again, we rewrite this function as in this form. And the derivative of this function is minus 4 times x squared minus x to the minus 5 minus 4 minus 1 gives you minus 5. And inside function's derivative, which is this one's derivative, it's 2x minus 1. Okay, so at the end we have this. We do similar things. We have quotient. Okay, we will apply that rule. Don't forget that. Okay, but inside we have some complex functions. Okay, that's why you need to be careful while taking derivatives. So this one's derivative is cosinus pi x times inside function's derivative, which is pi, times the second one minus first function times the second function's derivative. So this one's derivative is pi cosinus pi x, and this one's derivative minus sinus pi x times pi, okay, over the denominator square, okay? So what about this? Again, we rewrite the function to make it easier to take derivative. So how do we integrate? You can see this as a product. So first one's derivative is 1 times the second one plus first one times the second one's derivative. The inside function is 1 plus x squared. That's why its derivative is 2x. We write it here. Okay, and at the end we have this You don't make it simpler. You don't need to make it simpler. So now we have this. Again, we see that we consider it as a product. First one's derivative 1, second one's derivative is this one's derivative. What about it? So here we have cosinus and the inside function times inside function's derivative. So this one's derivative, okay? And x comes from the rule, product rule, okay? As the first function is x. That's why we have it here. Okay, and this one's derivative is 1 over 3, right? Because you can see that as x to the 1 over 3. So you just take this one's derivative. Okay. So here we have 1 over 3 times this one. So you get this. You just rewrite it, but you can finish it here too. Okay, you know the rest. You just need to be careful while you have something a little bit different than x when the inside function. In the inside function. So here we have sinus of sinus x squared. So what do we do? First, we start with the outside, the function in the outside, okay? So the derivative of this function is cosinus, and we have the rest times inside function's derivative. We have the same times this one's derivative. Here again we start with the outside. So we have cosinus again times the same as inside function times this one's derivative. Okay, this one's derivative. So we have again the same functions until here, and this one's derivative, it's cosinus x squared times 2x. Okay, this one's derivative is cosinus x squared times 2x. Okay, and at the end you have this. What about this? So again, you can think it's like x plus square root of x to the 1 over 3. So we have 1 over 3 times this times inside function's derivative. Okay, and here we have the same. So this one's derivative is 1, because this one's derivative is 1, plus this one's derivative, which is this. Again, exactly 1 over 2 square root of x. Okay. So we just do some operations to make it in the same fraction. That's why we write it here. 2 square root of x plus x over 2 square root of x. Okay, and as in here we had 3, that's why we have 6. If you want, we can simplify it to, oh, sorry, we have some here. Sorry. Okay, we have exactly this fraction. So, okay, now remember these equalities, okay? So we will find the derivatives. So the derivative of e to the 3x is 3e to the 3x, because as in here, if you have e to the some function in terms of x, you find its derivative. Oh, this is not equal. This can be written like this. The derivative of this equal to. Let me write it clearly. The derivative of this, okay? And again, the derivative of this. So how do you find this one's derivative? You first take the derivative of this power, which is g prime, and you write the same function, e to the g, okay? So you take this one's derivative, which is 3, and you write the same function in here, e to the 3x, okay? And what about this? You take this one's derivative, 3x squared, over, you just write this one again here, okay? by this you can find the rule. So these ones were easy. What about this? Okay, remember this equality again. If you have some constant here, a, and g to the x, a function in terms of x, this is exactly the same with e to the g of x, but you write ln of a, okay, because ln of e is equal to 1, that's why we don't write it here. But if we have some constant number a, which is different than e, then we write ln the logarithmic function of a. Okay. So let's write this one as in this form. Okay, y equals to this. So this is exactly equal to this equality, 2 to the y equals to x. Okay, this is exactly the same with this. Now we can take the derivative of both sides. So 2 to the y prime equals to x prime. X prime is 1. The derivative of x is 1. What about this? We just apply this rule. Okay, it is 2 to the y prime. Because y is a function in terms of x. Remember, that's why we write y prime. And ln of 2. Okay, as here we have the constant 2. So we remember this is equal to f of x. So we want to find the derivative of f, which is exactly the same to find y prime. Okay, that's why we isolate y prime. Here we have. So this is, remember y equals to this. That's why we put it here. So we have x ln of 2 in the denominator. So we have this equality, y prime equals to this. As we want to find f prime, we have this equality. Okay, this is a nice trick. You need to know this. Okay. So what about this? We rewrite this given logarithmic function to make it easier to find the derivative. So here we have a quotient, then we can write it in this form. We have product, we can write it in this form. So at the end, we have this logarithmic function. Okay, so how do we find the derivative? We find each one's derivative. Okay, this one's derivative is 2x over x squared. Remember, inside function's derivative over inside function. So for this one, we have 3 sine squared x over this. And for this one's derivative over itself. Okay, so you can here you can see we have sine squared over I made a mistake there, sorry. This is 3 sine squared times cosine squared, the derivative of sinus, right? So now we can simplify it. So we have cosines over sine. So we have cotangent x, okay? So, and you can easily simplify these ones again, okay? And it's again easy. You have this one in the denominator as in this form. So we can simplify them, okay? We have this at the end, okay? So remember again, I made a mistake there. Sinus 3 sine squared x times cosine squared should be. What about e? Again, we rewrite it as in this form. So what's the derivative of this function? It's minus 4 e to the minus x plus e to the x minus 2, minus 1 minus 2, okay, times the inside function's derivative. So we have this one in here, okay, and this one's derivative is, so we have e to the minus x, what's its derivative? It's minus e to the minus x, and this one's derivative itself. So we have this. Now again, we will find the derivatives. We're given this function x to the x. We rewrite it as in this form, e to the ln of x to the x, okay? Because, you know, if you have something like this, let's say x, sorry. So if you have same in here, then you have already x, okay? We apply that property. We use that property, sorry. So we have this, e to the ln x to the x. And another property of logarithmic function, we can write x ln x, okay? So what's the derivative of this function? We have e to the sum function in terms of x. We apply that rule. So this one's derivative, the power's derivative, times itself. This one's derivative is it's a product, so we take first one's derivative times second one. So 1 times ln of x plus first one x times the second one's derivative, which is 1 over x. And we have the same here. So we have ln of x plus 1 e to the x ln x, okay? Now we have this question, f of x equals to ln of x to the cosine of x now. We apply the same property, okay? We use the same. So we have this now, okay? And it can be written in this form. Now you know how to derivate it. So this one's the power's derivative times itself. Okay, this one's derivative. You have a product here. So it is minus sine x times the second function. Okay, plus first one cosine x times the second function's derivative, which is derivative of this function. Okay, it is 1 over ln of x times inside function's derivative, which is 1 over x. Okay. Let me think if I did. So this one's function is, this one's derivative is 1 over, I made a mistake there too, I guess. Yes, I made a mistake there, I guess. Let's try together. So here we have ln of x. Right, we want to find this one's derivative. So first, this one's derivative is ln of x's derivative over ln of x. And now inside function's derivative, which is 1 over x, right? So here we have 1 over x already. So we have 1 over x times x squared, ln of x. Okay, this should be x squared. Okay, so here we have x squared too. Okay, times the function itself, the function itself. Okay, so here we have minus sine x ln of x plus cosinus x squared ln of x times the function, this function. Okay. Now we will find implicit differentiation. So we just take both sides derivative, but here we consider y as a function in terms of x, as it's given in here. Okay, so we just need to be careful while taking the derivative of this function y. Okay, so we just rewrite it to be to have a sum or subtraction, because while we have this, we have a product, so taking its derivative is a little bit hard to, than this was. So that's why we rewrite it. Okay, first one's derivative is 5x to the 4 plus this one's derivative. So we have two functions, okay? The first one is x to the 4 and the second one is y. So we have a product in here. So first one's derivative is 4x to the 3 times the second one plus first one times second one's derivative, which is y prime. And here we do the same things. So here we have taken the derivative of this one but with respect to x first. So we have 3y to the y squared plus, now we have 3x times this one's derivative, so the y squared's derivative. So it is 3x times y squared derivative is 2y prime. Okay, that's why we have 6xy prime. Okay, and this one's derivative is this again. So we make some operations and get, what do we get by doing these ones, these operations? We get y prime. We just simplify here. Okay, we divide by this parentheses, both sides. Okay, we obtain y prime, the implicit differentiation. Why do we say implicit? Because this derivative contains not only x but also y inside. Okay, that's why we call it implicit differentiation. So what about this one? We have again 4 cosine of x minus y equals to 1. So we take both sides derivative. First here we have minus 4 sinus x, this is the derivative of 4 cosine x, times the second one, plus 4 cosine x times the second one's derivative, which is cosine y, times y prime, because here we see it as a function in terms of x. Okay, so we have y prime here, and this one's derivative is 0 because we have a constant function. And we do the same operations to obtain y prime. Okay, it's tangent x tangent y. So here we have tangent x over y equals to x plus y. This one's derivative is easy, 1 plus y prime. This one's derivative, you already know these ones better than me, so I don't explain it clearly. Second squared times this one times inside function's derivative, x over y's derivative. So it is 1 over y minus x over y squared. You can write it x times y minus 1. Okay, you can either take the product rule or quotient rule. Okay, you will obtain at the end this one. So again, you just simplify y prime, you isolate it, sorry. So you get the implicit differentiation. And this is another example. So we take both sides derivative with respect to x and get this equality. Okay, so we here we have, if we multiply 2 times square root of xy both sides, we obtain this. Then we write the ones with y prime on the left and the rest on the right, and divide the multiple of y prime each side to isolate y prime and get this function. We'll use implicit differentiation, okay, to find the tangent line. Okay, now we're given this equality. We want to find an equation to tangent line at this point. So first we take both sides derivative with respect to x and find y prime. Now we will find an equation. So we can consider it as this form, as in this form. So this is slope. Okay, how do we find it? We find it with this rule, as we wanted this equation to at this point. So here we have x0, y0. Okay, so y prime 0 gives you the slope. Okay, so for this one, for y prime, we will find the slope. So we put x equals to 0. Okay, so we know x equals to 0. What about y? We know y equals to 1 over 2. okay, because the point satisfies these two points in the reals, okay? So we just plug x equals to 0 and y equals to 1/2 to get the slope, which is 1, okay? Now, then we have this equality. So I wrote it here, b, and there c, to don't make a confusion. Let's write the c here. Okay, so we have this equation now. How do we find this c? We just plug 0.0, 1/2. Okay, we just plug y equals to this and x equals to that. So we find c, which is 1/2. We just plug into the equation. Okay, so this is the tangent line at this point. Okay. What about this? Again, we find y prime by implicit differentiation. Now what do we do? To find the slope, we now plug x equals to 3, okay? Because we are given this point. So we plug x equals to 3, and here we get 9/13. Here we plug x equals to 3 and y equals to 1, okay? Don't don't forget that point. So we have 9/13. This is the slope. We find c. How do we find it? We just plug this point into this equality and get c, the constant. Okay. Hence, this is the tangent line at this point to this curve. Okay. So this was the last question. If you have any question, you can attend the office hour, which is on Friday between 5 p.m. and 7 p.m. Okay. See you there. Take care.